Well, hey, folks, welcome to the Nurse Mark and the Green Nurse podcast,
where we bring you hope and inspiration for growth and healing. We're here to change the dialogue and stigma around what it means to feel good or be high. Hence the H for hope, I for inspiration, G for growth, and H for healing.
You know, Sherri, we often talk about things that people don't really want to talk about. However, they're important subjects that need to be discussed to decrease the stigma for healing.
Absolutely, Mark. And in 2021, we've been profiling cannabis nurses, midwives, and health professionals. We've been highlighting and illuminating health professionals in the cannabis space as we are truly in revolutionary times where we're changing how we approach and take care of patients.
You know, we don't wake up one day and just decide to enter the cannabis space, right? There's usually a compelling story that goes along with that plunge. Like, what makes someone enter into the cannabis space as a researcher or a practitioner? Sherri, will you please introduce our guest?
Of course I would. I'm very, very excited to introduce Dr. Kevin Spelman. He is a molecular biologist, a phytochemist, clinician, and herbalist who has worked with medicinal plants in the field, in the clinic, and in research models, including clinical trials and preclinical models. His clinical experience began in late 1989 and progressed to a group practice of MDs, DOs, doctors of osteopathy, nurse practitioners, and PAs, and has stretched through 30 years, 4 states, and 2 countries. Dr. Spelman has also advised the White House Commission on Complementary and Alternative Medicine. This was the Clinton administration. He is a past National Institutes of Health mouthful. Here we go. He is a past National Institutes of Health postdoctoral fellow where he studied cannabinoid signaling and was the first researcher to predict and demonstrate cannabinoid ligands in Zanthoxylum as well. I don't know if I said that right.
You
as
did.
well as a novel pharmacological target, the PPARγ for cannabimimetic compound in Echinacea. We've talked about Echinacea before. So his research history includes investigating plants for brain and ovarian cancer, clinical investigations, immunological studies, cannabinoid signaling, and chemical analysis. So international research has included the analysis of nutrient levels in teenage women in West Africa, working with children with neurological disorders in Central America, and investigating plants against malaria in Paris. Dr. Spelman has been an adjunct assistant professor at the Massachusetts College of Pharmacy and Health Sciences, an adjunct professor of botanical medicine at National University of Natural Medicine, at Bastyr University of Naturopathic Medicine, and a distinguished lecturer at Maryland University of Integrative Health. Wow, that was a mouthful. I'm not done yet, guys. This gets even better.
Oh, hold on.
So he's
and I get the big question that's going to start this whole thing off. Go, Sherri.
That's good. Okay, so here we go. We're going to wrap it up and then we're going to introduce. So he's published, you guys ready for this? 28 scientific and industry papers and 6 chapters on medicinal plants. Dr. Spelman currently leads health education and research, a consulting service for natural products and cannabis industry, assisting natural products companies in the research, scale up, formulations, product development, and meeting regulatory requirements. As a formulator, you guys ready for this? He has over 31 SKUs in both cannabinoid-based and non-cannabinoid-based products. And he's co-formulated many products for use by over 30 professional sports teams and in 3 branches of the military special services. That's big. So Dr. Spelman also publishes an audio science journal on natural products for clinicians called the Spelman Report, Phytopharmacology Review. Boy, Dr. Spelman, we have a ton to talk about. Welcome to the Nurse Mark and the Green Nurse podcast. Thank you so much for joining us. We're really, really honored.
Okay.
Well, Mark, Sherri, thanks for having me. It's great to be here.
It's great to have you. So here's my question, and it's really an important one, Doc. When do you think your career is going to start to take off?
I still wake up every morning and wonder what I do for a living.
Oh my gosh.
It's so difficult saying, people say, what do you do? I'm like,
No, right?
Well,
I do just about everything. I'm the plant man.
oh my gosh, that is quite the resume.
It is.
And man, that we have so much to talk about, Sherri. Kick us off.
I know we do.
There's so many areas that we can dive into. And
we want to bring you all the meat and potatoes, and there's a lot of good content here. So just the big thing, the big thing that a lot of people always like to know when we're interviewing them is what brought you to cannabis? Like what led you down that path to start to start researching the plant, learning about the plant, and utilizing the plant. Like we said, we don't all wake up one day. There's usually a story. So what's your story?
So I guess my story is teenage use. That's where it started. And I was blown away. I grew some beautiful plants in my parents' backyard, which got ripped off, unfortunately. I never got to partake in them, but I sprayed them with fish emulsion almost every day. By the way, I know there's growers out there saying, what? You could have done so much better. Well, I didn't know what I was doing. I was 15. But they were incredibly healthy, and my backdoor neighbors took them. So hopefully they were good. Guys, if you're listening, I hope they were good.
Yeah, somebody enjoyed them.
So you definitely did not have stigma to work through, which is good.
I did. So
you did? Oh, okay.
Yeah. I stepped away from cannabis for many years. Through most of my education, I actually didn't use cannabis.
Mm-hmm.
This is actually the most open I've ever been about this. Shortly after my education, I realized that life was a little bit easier for me with some cannabis in my life. Yeah. So long story short, I guess where it really started happening again was in my PhD process. I was so stressed out. I was working a full-time job. I was teaching full-time. I was researching full-time. I was driving back and forth between a college I taught at that was like 300 miles away and the lab. And I finally started using cannabis again. And it helped tremendously. I was starting to get a little crispy, as you can imagine. And then amazingly, during my PhD process, I was actually working on the endocannabinoid system, except back then, we didn't know it was the endocannabinoid system because I was working on PPARγ, peroxisome proliferator activated receptors, which, by the way, tons of medicinal plants and food plants actually activate. Now, why is this important to us? Well, PPARγ is key in cholesterol levels. It's key in insulin sensitivity or insulin resistance. It's key in diabetes. It's key in immunological function. It's got all kinds of activities. And so I was studying Echinacea and PPARγ, which was a novel hypothesis at the time. Nobody had done this. Turned out the biggest thing I learned there was that I had to sell the people around me on funding me to do this because there was no data. And I successfully did that. But as I was going through all that research, I kept running into the cannabinoid receptors. And so this took me eventually to NIH, where I ended up doing cannabinoid receptor screening and signaling. And they came to me one day and said, hey, we need a plant that's not cannabis that activates cannabinoid receptors. And I said, oh, that's easy. I said, Echinacea. And they walked away and they came back 2 days later and they said, that one's already known. Do you have one that's not known? And I said, oh yeah, that's easy. How about Zanthoxylum? Now, Zanthoxylum, probably many of you don't know that name, but it's prickly ash. It's also a Szechuan pepper in the Chinese model, right? So turned out I was right, and we published a paper on that. And by the way, we found CB1 receptors on immune cells, although that was a minor part of our study. We didn't want to dive into it too far because they would have asked us to go into all kinds of backflips in molecular biology. But yeah, we found some good stuff there. So that's kind of how I found my way in. Now, even when I left NIH, I hid my cannabis background because it would hurt me as a scientist, right?
Right.
So it was only probably in about 2015, after my second International Cannabinoid Research Society conference, which is a great group of scientists. After my second one, I decided to come out of the closet.
Is that at the University of Colorado?
No, it's all over the world. They go back and forth between North America and Europe, Eastern Europe, depending on the year. This next year, it's in Ireland.
Ooh. That's one conference that I have not attended, I think.
It's fantastic. It's very nerdy. It's a bunch of molecular biology and biochemistry, but it's what's coming in terms of, it's ahead of the clinic, but it's what's coming into the clinic.
So exciting. Wow.
It is.
So here's a question. So there's a lot of people, Mark and I do morning podcasts and we educate, and oftentimes we're talking about receptors and signaling and that. Let's talk a little bit about cannabinoid signaling for our new viewers who may not know what that means, because I think it's a good topic because we can.
Do you know how excited I am right now, Sherri?
I know.
Oh my
I know,
God.
Mark.
This is like, Dr. Spelman.
I know we are. We're cannabis nerds too.
Signaling.
His tail is wagging.
Oh, it is. Totally. Absolutely. Let's go.
Okay, so that's a big topic. Can you ask me more of a targeted
specific
question?
one?
Yeah.
Let's talk about cannabinoid signaling. How about in regards to the formulation of products?
Okay, so first of all, cannabinoid signaling, right? There's CB1, there's CB2, and what's been called in a colloquial term, a cannabinoid receptor with an ion channel attached, which is TRP V1. And all these receptors have a role in pain. And interestingly, CB2 also seems to have a role. It's usually considered immunological, but it also seems to have a role in addiction and anxiety. Some of the newer research is showing. So this signaling that goes on, I think the easiest in a layman's way of putting it is when you start the signaling of the cannabinoid system, really what you're saying is chill. Just chill. Whether it's the nervous system and you're like, hey, man, let's just take it easy here. Or whether it's immune system saying, hey, guys, you don't have to go looking for invaders right now. Just take a chill pill and relax and let's watch the tube a little bit, right? So that's really what a lot of that signaling is a down regulation of vigilance in so many ways of thinking about it. Now, there's exceptions to that where it can upregulate, but for the most part, it's a down regulation of that.
It's just like an adaptogen, it helps our body. It's like in the on-off switch, right? The signaling turns on, turns off, depending upon what's going on in the different areas of our body.
Yeah, no, you bring up a really good point, and I hear a lot about homeostasis and cannabinoids, right? But I think of it quite differently, because if you think about homeostasis, there's only three systems in the body that are truly homeostatic. One of them is blood pH, one of them is oxygen tension, and one of them is temperature, body temperature. Everything else is more allostatic. What do we mean by allostatic? Stability through change. In other words, allostasis means we're going to make a huge change, and that's going to bring us back into balance. And so think about it this way. For those of you out there who, when you stand up really quickly, you get dizzy. In order to not get dizzy when you stand up, you have to have a bit of an allostatic response. Blood pressure has to suddenly change, right? When you stand up quickly. And so in this sort of way, cannabinoids to me are more allostatic than they are homeostatic. Now, the result is the same. We're getting to a place of constancy. But because cannabinoids are generated on demand, right, that suggests an allostatic response.
It's situational.
So stability through change.
Situational, exactly. Exactly.
Okay.
Stability through change. Yeah.
Right. Okay, that's very interesting. Really cool. Wow. Love that.
Yes.
Would you give us an example? Give us an example of what might look like in a condition.
Sure. So let's say that you are fighting a bug, and the bug comes in, and TNF alpha goes up, IL-6, all these cytokines go up, right? All these inflammatory immune mediators are released into the body, and so inflammation is rampant. Well, the way to bring that down, one way is through CB2 signaling, right? So that's going to dampen all of that, so we don't go out of control. If we go out of control, we could go to a cytokine storm, much as the way that COVID patients die, right? So in this sort of way, we are. This is an allostatic response, not a homeostatic response.
Right.
We are getting back into homeostasis, but we're doing it through allostasis, not through homeostasis.
Okay.
If that makes any sense. Okay. I sound like a pedantic, like academic nerd here, but
no. This is really
maybe
good.
I am.
It's me to no end. Like, this is a great conversation.
It is a good conversation. Because it makes sense, if there's only three, pH, oxygen, and temperature that really are homeostatic, it does make sense because our bodies are constantly going through change, right? And so the allostatic nature of the cannabinoids is to provide stability through that change. It's to assist us so we're not too high, not too low. We're just right.
Exactly.
Right.
Exactly.
Yeah.
Goldilocks zone.
It's the Goldilocks syndrome, right?
And when we get too high, or we get to, or the bed's too hard, we have to have a response to mitigate that, right?
Right.
It's not like you always pick the perfect bed. Sometimes you end up in the bed that's too hard, right? And so your body has to respond to that.
Yeah, I love that. I love that blood pressure, that change in blood pressure example. That clarified it for me.
Yeah, me too.
Yeah.
All right, let's talk research.
If your blood pressure just stayed homeostatic, you would faint when you stood up.
Oh yeah, exactly.
Right?
If it didn't change, if it didn't, compensate, right. Makes sense.
Yeah.
Yeah. No, very good. Sure. So let's talk some research. I love research because we present,
me too.
And you've done a ton of it. So
it's one of my favorite things to do, actually.
It's one of my favorite things to learn, as long as I'm not doing it. I like to learn and teach others about the research that everyone else does. So it's so
Listen,
good.
I like to think of you're like a translator, Sherri. I look at you as like a translator. You take all of that scientific research-based jargon, and then you turn it into something that I can consume.
Well, here's the reason why, too, is it has to do with having ADHD, and also part of it is how I can express myself better so my receptive language and expressive language. So I've had difficulty with receptive language. So sometimes it takes me longer to do things, but that time that it takes to do things, I'm able to make up for it in how I express it. So I can express myself. So it's all good. So thank God I have cannabis, which helps me to adapt.
Yeah, that's absolutely right. So we're going to talk research, right? So let's talk
research.
Wow.
Some of the things you've done.
You investigated plants in regard to if they had any effect on brain or ovarian cancer. Talk about some of the studies that you were involved in on that.
Yeah, so for brain cancer, this is while I was at National Institutes of Health, and what we were looking at, or what I was looking at, unbeknownst to my lab chief, was I was looking at a couple of different herbs in terms of response to brain cancer, and specifically, I was looking at what's called an orphan nuclear receptor, called the estrogen-related receptor, not the estrogen receptor, the estrogen-related receptor, which it's known as an orphan nuclear receptor because we don't understand what the endogenous ligand is yet. So it's orphaned. So it turns out that there's a fair amount of plants that bind to that, and those isoflavones that we find in soy and red clover and plants like this actually bind estrogen-related receptors. And these have a really strong impact on the growth of cancer in the brain. And not just the brain, but also in the brain. And so I was able to look at this, and I found red clover, which, by the way, has traditionally been used for cancer in a very significant way, in that it's part of two different very strongly respected herb formulas that are used for cancer. So 2 different formulas, red clover's in both of them. So I jumped on red clover and had a look, and sure enough, looks like through estrogen-related receptors, it actually inhibits the growth of cancer. So that was fun and nice to see.
I would think so. Anytime we have a positive, result and outcome.
You want to know what a nerd I am right now? I actually just typed that down. Just took notes.
Well, yeah, you should. Hey, you know what, Doc? Can we step back for a second? I don't think a lot of people understand what is the National Institute of Health. Like, I know because I look up a lot of research that's been done through the National Institute of Health. What is that organization? What is it? What is it all about?
Good question. So first of all, from a 30,000 foot level, in a way, it's the best cathedral of science in the world. Let's put it that way.
There you go.
Yeah. Michelangelo did the ceilings in the NIH. I'm kidding, but but you know what I mean?
Listen, I think I would agree with that. Like, a ton of the research that I've been exposed to has come through the NIH, and it's always well respected because it doesn't make it there unless it's been done right, by and large.
That's right. Let's hope.
Yeah.
It's National Institutes of Health because it's a bunch of different institutes within an institute, right? So National Cancer Institute, National Institute on Aging, National Institute on Drug Abuse. Like it's quite a all of them and more than that. And interestingly, if you really look at the funding, I remember going to a meeting one day and they showed this funding chart, a bar chart. And so NCI, National Cancer Institute, the bar chart was way up there, right? Everybody else was way down here. And I'm not kidding. I'm not exaggerating. The NCI is so well funded and the rest of us were scrambling, we're fighting over scraps, right?
Yeah.
But it's a really good group of scientists, of government employees. I've been given a hard time because I was a government employee at the National Institutes of Health. Hey, give me a hard time about that. It's the best science in the world. And in fact, most of the postdocs that are there, there's very few American postdocs there. And I don't know why. That's right. Most of them are either Indian or Chinese.
Yeah.
And there's a whole bunch of politics there that I'm not going to go into. But most American students, doctoral students that are looking for a postdoc, I think most of them feel like they can't get in because it's so competitive.
Well, you know what I say? Give it a whirl. Try it out. You never know until you apply.
Yeah.
Okay, so that's good because I didn't understand sort of the makeup of the National Institute of Health.
Multiple different institutions coming together.
Yeah. So when you proposed to do a study, you talked about it earlier. You had to scramble to find funding. Now I hear that that's a process and a half. Tell us sort of about how does a funding mechanism work? Do you literally have to go beg somebody and do presentation after presentation, and how do you actually end up being funded?
It depends on where you are. So if you're at a university, generally speaking, you have to bring in your own funding for research. If you're a PI, principal investigator, PI. So if you're one of the professors that runs a lab, a PI, then you have to bring in your own funding, unless you have been hired with the idea that they're going to give you whatever, $1 million for the first 2 years or 3 years for your research to get your research platform going, which happens a lot that way. But once that runs out, it's really up to you to fund. And this is why I actually didn't go into academia. I thought I was going to, because I watched the surrounding professor. My professor at UNC was really well funded, Dr. Nadja Chek, who was a saint, just really a wonderful person and a really great scientist and really smart. And I was 20 years her senior.
Really?
Yeah, when I was studying with her, but she's a wonderful, wonderful person. She put up with me, so
Yeah. Listen, I'm not gonna disparage that at all, because I got my first college degree at the age of 54. So listen, I was a lot older than most of the professors and the students. So
congratulations.
Thanks.
I finished my PhD when I was something like 50. So
beautiful. No better time to do it.
Right?
I like to tell people, if they think that they're too old for something, they're not. Just get in there. So
it's true.
Yeah. So the funding piece in academia, how is it like what would you have to do, like National Institute of Health, but like this brain cancer study that you researched that you did?
So if you're at NIH, then all you have to do is make a pitch to your PI, your principal investigator, your lab boss. You have to make a pitch to them and say, "Hey, I have this idea. What do you think?" But that's not usually how it goes. Usually how it goes is they say to you, "I have this idea. Do it." And I remember as an undergrad being shocked. I volunteered to work in this lab, and I had all these research ideas. And and I went my first day, and I was like, "Okay, so here's what I'd like to do." And he's looking at me like, "What? Who is this guy?"
It's like, "I'm sorry, Kevin, that's not quite how it works here."
Yeah, exactly.
But that's so good, though. I would be really excited. That means that you're motivated. You're coming in with ideas. Totally you're ready to research.
Exactly. I had all kinds of ideas, and I wanted to check it out. And he was like, "That's not the way this works here. You work for me. I don't work for you."
That's really cute.
Oh my gosh. Okay, Sherri, dive back in. Sorry to take us down that rabbit hole.
No, it's okay.
No, that's all good. This is really good. So
questions on.
Well, so let me just finish one thing there.
Yeah,
I don't think I've actually finished the thought. I saw that the professors around me struggling to get funded, and they had great ideas. And that's what really pushed me out of academia, because I didn't want to deal. I just didn't want to deal with. I didn't want to beg for money all day. And essentially that's a lot of what you do when you run a lab is you search for funding. And after 2008, after that recession hit, the number of grants that would be funded, the proposals that would be funded by grants from NIH went from something like 50% to 25%. And so it just, I think it was from 25% to 8%. That sounds more accurate. And so suddenly, when you have only 8% of funding going out to all the studies coming, then you have to study something very mainstream, because they don't want to fund something that's too far out there. It's like, well, it's an interesting idea. It might work, but probably not. So that kind of stuff doesn't get funded. So it really changed science in a huge way, that the recession that hit. And I remember that's actually when I was at NIH right after the recession hit. And I remember them coming to us and saying, "Hey, there's no money right now. So you must have some writing to do, right? You don't need to do lab work." And because when you do lab work, you need supplies, you need reagents, you need, tools. So it was an interesting time.
Wow. Very good, Mark. Yeah. So research. So, in your bio, we talked a lot about, we read some information about what you do. And when we are educating patients and providers, nutrition is really important. So part of your research also included the analysis of nutrient levels in teenage women in West Africa. So I think that's very fascinating. Would you tell us what that research looked like?
Yeah, so that was really, in a lot of ways, was geared towards social justice and attention to that, because the girls, I'm not going to call them women, because they were like between 11 and 13 that we were looking at nutrient levels, and they were just about to become married and then pregnant.
Oof.
Yeah, and so I don't know that this was what my PI was doing, but in my mind, that's what we were doing, is a social justice issue of, okay, let's show that these girls are, number one, nutrient deficient, and number two, discuss the fact that they're about to be pregnant in the paper. So that we need to, that's why we need to do this research, because we're going to make sure there's no neural tube defects that are going to happen here, right? Because we were looking at folic acid levels.
Right.
And interestingly, what we found was that folic acid levels weren't low, but what was low was B12. And the folic acid levels weren't low because groundnut, or we know as peanut, right? Groundnut is a major crop in many parts of Africa, including Nigeria, and it's rich in folic acid. And so they had enough folic acid, but they didn't have enough B12, which, by the way, you can also end up with neural tube defects that way.
Wow. So do we know why they didn't have B12? Like, was there anything that they were not eating? Like, what was any indication as to why the group of women were low in B12?
Great question, and that was over 20 years ago. So, so I'm gonna say, gee. I can make something up, but I really don't remember.
You know what? Feel free. I bet you it's going to be a good guess.
No, well, honestly, not a lot of animal products were very expensive. So that would be my guess, is that
not a
lot of B12 without animal products, although it is possible. But
interesting. Wow, very, very cool. Okay, here we got another one. Mark's heading to Paris tomorrow.
Oh, yeah, baby.
You did it. This is a really good one. So he's going to Paris tomorrow with his wife, Jamie.
I'm ready to go.
Yep. And so part of your research included analysis of investigation of plants against malaria in Paris. So that's a really cool one. So malaria, is deadly.
Listen, we don't really get that. I think in the United States, we don't understand what a plague malaria is in the rest of the world.
It's true. It kills over 1 million people a year, and basically, if you look at, we will know malaria again. Climate change is gonna bring malaria back.
I was going to ask, why don't we have that in the United States?
We did. It wasn't back in the 1800s and the early 1900s. It was in the southern United States, southeastern United States. But it's no longer there.
My grandfather actually contracted that. He was born in 1902, and he was in the military in the United States. He contracted malaria, and my mom would tell a story about, years and years later, he would have a spell where he'd just be shaking and shivering from just being so cold. That was related to that, I think. Yeah,
that recurrent fever of malaria, Plasmodium vivax, I think must have been the infection he had.
Yeah.
Falciparum is more common and more deadly, which, by the way, I got while I was in Nigeria doing research.
Oh, wow.
Yeah, it was, let me tell you, the chloroquine that they gave me, and by the way, I was in a chloroquine-resistant area in terms of the Plasmodium being resistant to chloroquine.
Because they mutate, right?
They mutate rapidly.
Yeah.
And that's a whole other topic that maybe we can touch on. But
we don't want to scare everybody, Doc.
Yeah, I ended up, the malaria was bad. The chloroquine was even worse. It took me, after I ceased chloroquine, it took me a couple of days to be able to walk a straight line. It looked like I was drunk. Wow. That was the side effect of chloroquine.
Just so I know, how did the chloroquine interact in your body that made it so icky?
Well, clearly it has some sort of neurological activity that is off target, right? Because essentially what you're trying to do is kill the malaria bug, the Plasmodium, with it. But I can't tell you specifically what it did. But the other thing that was there is I was on mefloquine while I was there, and mefloquine is nasty. I don't think we use it in the U.S. anymore, but this is back in 1997, 98, somewhere in there. And mefloquine was something that the U.S. used and most other countries weren't, because about 2 to 5% of people have a psychotic break on mefloquine.
Oh, wow.
And I actually saw a scene when I came back. I was at the University of New Mexico at the time. And I actually saw a scene in a hospital where a doctor walked up to another doctor, pinned him against the wall, put his forearm up into his neck, and said, with a bunch of expletives, said, "Why didn't you tell me that mefloquine was going to do that to me?"
Oh,
wow.
So he got really sick, apparently, on it.
Yeah.
And I had really bad anxiety on it myself.
And that's probably why we don't use it here in the U.S.
That's
anymore.
probably why we don't use it anymore. Yeah.
But
these were the drugs that were used to treat it. This is what, right?
Yeah. Well, methylquin could be used to treat, but it was also prophylactic. You took a dose every week, I think, is what it was.
Okay. Okay.
So that was the malaria part there in Africa, and then actually the contraction of malaria. I didn't actually do malaria research while I was there, but we did do this other research. We looked at osteoporosis in women. We looked at the folic acid and nutrient levels in young women. We looked at bone density in women. It was actually quite intriguing.
Well, that's a good topic, because I'm at that age where we're looking at bone density a lot more. Right?
Strontium. Do you know about strontium?
No.
Check it out. So strontium, micronutrient, right? And strontium gives you extremely hard bones. It will strengthen your tensile strength of the bone very significantly. I haven't looked at that research. Strontium. Strontium. I haven't looked at the research in probably 15 years or so. So you should probably do your due diligence. Yeah,
totally.
I'd search the National Institute of Health, Sherri.
That's a little too out there for the National Institutes of Health, I'm afraid to say.
Yeah.
Right. So what is strontium? What kind of a micronutrient is it?
Basically, it's a mineral type,
Wow. It's I've never heard of it. I love it. Yeah. I've been a nurse for 33 years, and this is it's fascinating.
See, Sherri, this is why we invite people like Dr. Spelman onto the show, because we get personal advice.
Get smarter.
Really what it's all about, Doc. We're all about just gleaning personal advice.
Picking your brain.
We lead the conversation that way so that we can extract what we need. It's really not about everybody.
To stay healthy.
Let's go back to cannabis, because CB2 receptors are located in the bone.
Right.
And it turns out that with CB2 signaling, what you're doing is you're increasing osteoblast activity, right, which builds bone, and you're decreasing osteoclast activity, which breaks down bone.
Right.
So now this hasn't been shown yet, but it's highly likely that things like Szechuan pepper or prickly ash, in other words, Zanthoxylum species, as well as Echinacea, have a very high affinity compound in there known as acrylamides or alkylamides, or alchemides, some people call them, that bind CB2. So it's likely, but hasn't been proven, that these types of compounds or these herbs would actually have a bone building effect for people.
That's what we need. I got to build those bones.
You know it. Absolutely. That's really good.
Yeah. Okay, I like that. Really good. Echinacea, pepper, and prickly ash.
Right.
So exactly. So cannabinoids.
So speaking of cannabis, let's talk about formulations. What do you think, Sherri?
Here we go. I know. I'm all excited about cannabis and Echinacea being together. And prickly pear and pepper. Let's all put this together and make a capsule for women.
Prickly ash.
So what drew you to formulating products? That's like the coolest thing.
Well, I've been doing it a long time, because when I was doing clinical practice, so I was practicing Ayurvedic medicine. I was trained in Ayurvedic medicine and Western herbal medicine. And so Ayurvedic medicine, traditionally what you do is you build the formula for each patient. You don't pull a product off the shelf and hand them a product. You build the formula for them. And so that's what I did. And so that started my formulation career. Although I didn't know it at the time, I was just doing clinical work, right, in my mind. But really looking at people's individualities and saying, okay, what does this person need? Them. So, and I have to say, I was very disheartened once. I had a couple of interns, medical students, in with me. And I had a patient come in, and they were sitting in the clinic with me. I had a patient come in that had UTIs, urinary tract infections. And so I put together a formula for her and all her life stresses that was going to deal with her UTIs. And I walk into the dispensary, And the medical students are copying it down madly, going, oh, this is the UTI formula. And I was like, no, this is not the UTI formula. This is her UTI formula.
Right.
Yeah.
Right. See, there it is. It just reminds me, like, it's just her endocannabinoid system, her system is different. So every UTI, you have an antibiotic that's going to treat it. But when you're looking at adaptogens, Ayurvedic herbs, cannabinoids, it's going to be different for everyone, because everything that we do or don't do affects how our endocannabinoid system works.
Right.
And so it makes sense that it would be patient specific, not one giant blanket formula for all of the UTIs of the world.
Yeah.
Wow.
Exactly.
Makes sense.
So it started there. And then as I got more and more into the molecular biology of herbs and more into my model of understanding that herbs hit multiple targets, pharmacological targets, not just one. And I think that's the huge mistake we've made in modern pharmacology, is that we're after a single agent that hits a single target. And speaking of resistance, if you're treating bacterial infections, parasite infections, plasmodium, malaria infections, whatever, that bug is smart enough to figure a way around the target that you've blocked, right?
Right.
And so it really does take a network approach where you're hitting multiple targets all at once. And this is what herbs have always done. This is what our food plants even have always done. It's not just about one, many pharmacologists look at plants as a mess. It's like, well, there's a gem in there, but it's a jungle to find it, right? Well, no, it's not just one active component. You hear people talk about cannabis and it's got over 400 constituents. I can guarantee you that's wrong. If you look at corn and wheat, which are the most studied plants we have, we've got somewhere between, respectively, 3,000 and 5,000 compounds in each of those plants. Right. We know that because we've studied those plants inside out, right?
Right. I heard one researcher say there was 1,500 different compounds within the cannabis plant that they identified but not understood anything about them.
Now we're getting closer. Exactly. So
there's so much, like
there's so much.
You think about, and the plant's constantly changing too. Like, when you
depending on weather,
grows,
depending on
you
season.
harvest it. Yeah. So you can just, oh my gosh, you got universes of plants. That's really fascinating.
So coming from that model and formulating for me was a natural, because I'd already done a bunch of formulation for the individual. Now I was having to take a step back and do more of a public health type of formulation, right? It wasn't necessarily for the individuals, for the herd. Okay, and so what does that herd usually deal with? Like, what are the most common problems when we're going to deal with a UTI or cardiovascular disease? It's not just one target ever, right? There's multiple targets. And so this is one of the beauties of medicinal plants and one of the beauties of formulating. You can strengthen, you can have what we call a hero herb in there, and then you support that hero herb. Or hero herb, like Michael Jordan had a team around him, right? Even if Scottie Pippen is still pissed, Michael Jordan had a team around him, right?
Right.
And so he was the hero, but you had to have support. And in the same sort of way, we build formulas that way. We have to support that main actor in there.
Yeah, and I love the way you described, like, a bacteria is always looking for a way around whatever we're targeting, right? So you're just saying you're going to block off all of the exit doors. And that's
Exactly.
And then you have that deadly effect on the bacteria.
And it's the same thing with cancer, right? Cancer is smart. It figures a way around that single drug approach. And so now you're seeing a lot of oncologists using drug cocktails for cancer and for things like tuberculosis. And that's what herbs are naturally. An herb is a drug cocktail, right?
Yes.
Yeah. It makes sense because it's working on multiple different things.
Including
cannabis, which is, it's interesting. I talk about this a lot, right, Sherri? I talk about, the entourage effect and the fact that we all agree there is an entourage effect. We know that it's a phenomenon, but we just don't really understand the exact mechanism of how it all works. And it probably goes back to the fact there are 1,500 compounds that we don't understand all of them.
Yeah. And it's just doing things that we haven't studied yet.
Yeah.
And then you throw in the SNPs, the single nucleotide polymorphisms, those slight changes in DNA that we have. And so for one person, in a plant, compound Z and X and T are really active for them. But for another person that's got that SNP, it might be Z, X, T, and W that are actually super active. So it just, there's so much, it's really
just keeps growing, right?
It does. It does. A formula should be like a glove. It includes all 5 fingers, not just one target.
Love that. Get your glove on. That's what we're going to be telling doctors. Come on, doc, put your glove on.
Yeah, include all of them.
The last time I did that, I got a anal exam. I
right. Last time you made that request. Oh, I know, right?
And he seemed eager to do it too. So I don't know what that was about.
Yeah. Listen, anything to remain healthy. That's what I say. Absolutely.
Exactly.
Yes.
Exactly. Wow, this has been really good. So I'm just going to ask, because I'm a product nerd. I'm not going to lie. I love experimenting. I love exploring. Between the funguses, the mushrooms, the adaptogens, the Ayurvedic herbs, the supplements, all of that stuff. I love to incorporate it into my life. It's truly helped heal me and has kept my cannabinoid requirements down. The more I use these other micronutrients that are found in funguses and the different plants and the micronutrients and diet and the things that I consume. So I like to experiment. So I'm curious to know, what are your top 3 product formulations that you think are the best ever? Because I want to try them.
Well, let's see. One I can't talk about because it's not on the market yet, and so I can't tip my hat. But I'm super excited about that. The military and NFL are super interested in it, and it could make a big difference. So there's that one, and I won't say much more about that.
Okay.
I've done some incredible formulations for Zips, a new cannabis company that they've got completely the right idea. So what we did was we took sleep issues and we took anxiety issues, and we broke them down into different types of sleep issues and different types of anxiety issues. And then I formulated specifically for those differences. So we ended up with 6 different sleep formulas and 6 different anxiety formula or mood formulas. Let me put it that way. It's not just anxiety. And then you go through, and much like you would on eHarmony, you go through and you take a little survey, and then it matches you to that particular formula.
Right. Okay. That's very interesting. So, like, in other words, if a person has sleep apnea versus if they don't, or if a person has difficulty falling asleep, staying asleep, waking up, nightmares. So they answer all these questions based on their sleep habits, their hygiene, and what they do. And then it spits out what might be appropriate for them to try. That's brilliant.
I mean, individualized medicine?
Personalized medicine.
Personalized medicine?
Wow.
Yeah.
Quick question. So in those particular formulations, is it just cannabinoids, or is it cannabinoids and other types of micronutrients and adaptogens?
I'm glad you asked. It's both. It's adaptogens, it's cannabinoids, it's terpenes, it's dependent on the formula. And by the way, we on our first trial, so we had 120 people or so that got samples and went through the protocol and got their samples. We had an 89% success rate in terms of,
Oh, really and now let me ask you, I think, well, when the FDA looks at a new medication and it goes through the clinical trials and gets to the authorization point, isn't it like a threshold of like 40% positive efficacy to tip the scale in the positive?
I think it depends on the drug and what's already out there. So I think you could probably get away, for example, with a cancer drug that, let's say there was an orphan cancer that didn't really have any drugs. And I think if you had a 25% hit rate or a 25% success rate, I think the FDA would probably accept that. So I think it's going to depend on the category.
Circumstantial always, right?
Yeah.
But 89%.
89%. Yeah. In other words, the survey matched, our algorithm matched these products really well.
That's really cool. Wow.
So that's a top. I'd say that's top there. And then I'm working on a practitioner line with a company, and I'm not going to tip my hat there yet either. But that's got about 30 products, 30 different formulas for practitioners. So that's super exciting.
Really exciting.
There's a lot of stuff you can't tip your hand on here, Doc. What's going on?
No,
what are
tell
you
us
doing
some
out
secrets.
back there? Yeah.
So,
yeah, we're going to have you back on the show then, you know, after you have launched these things, because we have to know more about it.
And then I just did, so what I can open and tell you about is Infior is a great company that's done mostly skincare and cosmetics. And now I just did a couple of formulas for them, 3 different formulas. One's an adaptogen, one's a sleep formula, and yet a third formula in there. And I'm actually now working on a 4th formula for them as well. But there's 3 formulas that are already out there. And they're on their way to Europe now as well. So that's a good sign.
Yeah.
That is so exciting. Do you get any rest yourself? You're so busy.
I'm insanely busy. It's
that's amazing. Wow.
It's
formulating research that's just so powerful. What is the future of plant medicines? Like, what is the future, you know, in the traditional system? How do you see this playing out? What does it look like to you? Like, seriously, like how do you envision, you know,
I think it depends on the country you're in. So let's start right there. So first, let's look at what the World Health Organization, one of their statistics. They show that 80% of the world's population still uses plants as primary care medicine, right?
I didn't know that.
Yeah, that's huge. Now, if you look at that and then you look in the US, I'd have to say we're developmentally delayed, our medical model here.
Absolutely.
Because we're not.
It's flipped. It's flipped. We're not first world in that world.
We're not. Exactly.
Right.
Exactly. So go to Germany now. And what you'll find is that probably about 50% of all the scripts that are done are phytopharmaceuticals of some sort. Wow. In other words, plant medicines. Not isolates, but plant medicines.
Combinations.
And most docs will prescribe them. So there's not a bias there. Like here, you say something to a doc about herbs, and they're suddenly biased. In fact, while I was at NIH, I had to hide who I was there because they would have walked me out of the building.
Absolutely. Yeah. Yeah.
So in Germany, you talk about plants, and they're like, "Oh yeah, I just prescribed that this morning." You know,
yeah, well, I mean, it's a different healthcare system in Germany, right? It's a nationalized healthcare, and I'm encouraged that they, you know, dive into that area.
Yeah.
Well, in Switzerland, they're doing a lot of homeopathics too. You know,
Switzerland's
couple of doctors.
Too.
There's a couple of integrative functional health doctors that have private practices that were actually going to Switzerland and getting these homeopathic formulas for infusions with their clients. Really, really fascinating stuff. Yeah. They use it as we come on, America, hurry, take your time and hurry up. Right? Seriously.
Well,
wow.
I mean, let's be honest with ourselves about our healthcare system. It's a for-profit model, which has some advantages, but that also has some disadvantages. And one of those disadvantages is that anything that competes with big pharma is going to get squashed.
Always. The pharmaceutical company is the highest spender in Washington, D.C. for lobbying.
Yeah. And they also
the pharmaceutical companies for lobbying Congress and the Senate on anything related to healthcare and pharmaceuticals. So
they also use more water than any other industry.
Yeah.
Really?
Yeah.
I didn't know that. Interesting.
Well, we can be change agents and hope for the best.
Well, and that's what I have a feeling the Spelman Report has to do with that, right? You're providing information.
I hope so.
Spelman Report, right?
Yeah.
To help change the world. The miracle. The miracle is a change of perception, right? So tell us about the Spelman Report.
Yeah. So essentially, what I'm trying to do is educate clinicians that want to use medicinal plants and or micronutrients. But so the first half of the Spelman Report is me. I'll pick out some new research that I'll talk about. Usually, it's very clinically relevant. And then I'll have a topic of the day, which I take a deep dive into something. I just did CBD and seizures on the last episode. And then I'll have the last half, I'll have a clinician or a scientist that is doing the work. And I'll just interview them and we'll talk about what their work is and what they're doing and what they find in the clinic and what works for them. So
Wow.
I'm really trying to put something out there that's useful to clinicians out there.
And where can we find the Spelman Report? Where do we consume this?
The SpelmanReport.com. There is a script fee, unfortunately, but I had to do it because I was losing money because I pay a team of researchers. I pay a team of researchers to keep it going. So it's not much. It's like $8 a month.
That's nothing for good quality,
Exactly. Information.
programming and research and, for you to share your knowledge.
Yeah. Wow.
Love it.
Excellent. What's the future look like for you, Dr. Kevin Spelman?
Oh boy, the future for me. I hope to find a little place in Driggs, Idaho, where I can ski probably 5 to 6 months a year.
But don't you dare bring cannabis with you.
I know.
Idaho, not
I know.
cannabis friendly, Dr. Spelman.
I know.
But it's a magical place. It is beautiful, right? I'm with you. That's a great place to be if you skate.
Yeah, exactly.
Yeah. Mm-hmm.
So this has been really wonderful to have you on tonight. Do you have any words for our viewers before we go? Because we're going to definitely have you on again once you're able to make those announcements. we want to be one of the announcers.
Yeah, I do. 2 things to think about for your viewers. Number 1 is your attitude. If you're going through life and you're pissed off all the time, the people around you are going to be miserable. So if you can't do it for yourself, do it for the people around you. Number 2, if you don't get enough sleep, you are aging your brain, and that is going to show up when you're older. So take care of yourself. Now, obviously you have to eat well and all that, but sleep and attitude are really key.
Oh, time to go to bed.
And on that note.
On that note, everyone, this has been wonderful. Dr. Kevin Spelman. If you look in the notes below, there's all kinds of information on how you can reach him and his website. Really, really grateful to have you on tonight.
Thank you.
And Mark, do you have any last words before I do my tagline?
I'm grateful for everybody who showed up to listen in. And Dr. Spelman, great having you here, talking about all the stuff that I really do love, the research and the mechanisms of action. That's what I love. So thank you for all of what you've done. And you know what? I really do think your career is going to take off like very soon. Anytime you're going to be, it's all happening now, Doc.
The tipping point.
That's right. You reached the tipping point.
Mark, have a great time in Paris.
Oh, thanks. I'm so excited. Yes, it'll be wonderful. And I'm going to, I'm really interested to go, Doctor. I'm going to find out what the cannabis scene is in France. Where are they on legalization? Where, what is the mood? Are people for this or against this? Like, I'll get a good viewpoint from there.
Absolutely, which is going to be very exciting. So everyone, thank you all for joining us this evening, and make sure you tune in tomorrow morning.
Yeah.
Right?
8 a.m.
Thursday, Throwback Thursday. Yep. And remember, everyone, what it's all about. Really, truly, it is about living your best life and helping others do the same. Thank you for joining us tonight.
All right. Good night, everybody.